let's have a look at this, right? We're looking today at quadratic inequalities. And there are actually two strategies to do this, okay? The two strategies are, there is a graphical method, and there is an algebraic method. Now initially, I do find that a lot of students have issues with graphing, okay? But you'll find that when I show you both methods, although graphing itself is a much harder skill than just working with algebra, this one here, this method, is a little bit trickier in terms of it's more error prone, right? You're more likely to make mistakes, and also, honestly, just takes longer, okay? So I really prefer the graphical method, but I will show you both ways. Let's just look at something like this, right? We spend a lot of time in maths looking at the right way to do things. I think it's just as useful at looking at why something might be the wrong way. So as a spoiler, this is going to be the wrong way to do something, but let's just see why, okay? X squared is greater than or equal to 9. We already know in the back of our minds that quadratics and inequalities, they're just kind of things that are almost weird about the solutions, right? Quadratics can have two answers. Inequalities, we have all these rules when we're working with them. Let's just say I treated this like a normal equation. Let's just say I took the square root of both sides. What do I have to remember when I'm taking the square root again? Plus or minus. Yeah, so there's a positive and there's a negative case, right? So I've got plus or minus 3. Let me think about that for a second, right? On the number line, what would this look like? This would look like, so my solutions are from plus or minus 3, my value for x is always greater than both of those. So I could just represent that like that. Would you agree, right? My answers have to be bigger than positive or negative 3. That's all I've done here. Don't write this down because it's not quite right. Okay, so just looking at this. Let's actually check if this is right. If I substituted in negative 3 into here, that works. It's greater than or equal to 9. In fact, it's equal to 9. Same thing with 3. And I can try a number over here. Like if I tried, I don't know, 5. I put that in here. Yep, 25 is bigger than or equal to 9. Can anyone see a problem with this though? Minus 2. Let's try minus 2. So this number line is telling me that any of these numbers should satisfy this inequality here. But if I try to put in minus 2, or minus 2 all squared, that's 4. And that's not greater than or equal to 9, is it? Okay. So obviously this is not going to work. And in fact, I'll just give you another example that show you it doesn't work, right? I'll show you another example. We've actually missed some solutions here, right? We've missed some solutions because if I tried minus 4, because this is a quadratic, because I've squared it, right, that gives me 16, which is actually greater than or equal to 9. So this obviously is not the right method that we need to use. Let me show you how we could solve an inequality graphically, okay? Because we're used to seeing equations like this. Now, x squared greater than or equal to 9, I can write that another way. I can write that with everything on the one side as x squared minus 9 is greater than or equal to 0. Okay. When I am solving things, I do like to have things in factorized form. What would this factorize to? Yeah, Chris? X plus 3, x minus 3. Right? It's the difference of two squares. Right? So factorizing is a key thing that we're looking for when we're solving things like this. Not only because it helps us solve it, but it helps us graph it as well. Right? What two things do I need to know about an equation before I'm graphing it? I need to know the concavity. So what's the concavity of this one? It's happy face, eh? Concave out, because the coefficient of x squared is positive. And I know that the intercepts are positive 3 and negative 3. So I can put that in there. And I'm going to draw this out. Okay, now why is this helping us to answer the question? Usually when you see your equations, there's something like this. Y is equal to this thing here, right? What do you think it means if I'm asking for, now I'm asking for this thing greater than or equal to 0. Or essentially I'm asking for when y is greater than or equal to 0. What am I actually asking for here? What does it mean for y to be greater than or equal to 0? Yeah, Matt. Okay, so think about what are your y values. Which ones are your y values? This is your y-axis. This is your x-axis, right? Your y values can go to the negative values, they can go to positive values, they can also be 0. I want when all the y values are greater than or equal to 0. Which section of my graph is that? It's all of these ones here. Yeah, above the x-axis. You can see that these ones are below. We don't want those. Right? We want all the values where my graph, the black line, is above the x-axis. So it's all the ones from here onwards and here onwards. How do I actually represent that as a solution though? Well, think about what you're actually asking to find. You want the x values where this is true. So I'll go back to this one and say, okay, for what x values is it above the x-axis? Was all the ones on, yeah, that's right, less than or equal to minus 3. So all the ones on that side. Or what's the other possible answer? Greater than or equal to 3, right? And if you wanted to represent the number line, what would it actually look like? It would look like this. So you want all the ones in this direction and all the ones in this direction, and that's what we get here, all right? That's how we can solve this graphically. If I was to now just change this inequality slightly, how would that change my answer? What if I had it the other way? What if I had x squared, sorry, I'll write it in the factorized form. What about x plus 3, x minus 3? What if I want that now less than or equal to 0? Which values do I want now? I don't want these ones. I want it when it's below 0, below the x-axis, right? So, from what values is it below? So now I've changed the question slightly. I want when this thing is less than or equal to 0, right? For what values is this below the x-axis? So which sections? Like here, right?
Between minus 3 and 3.
And between minus 3 and 3. So I'll draw my number line. Sorry.
This is like the other thing we did.
Yeah, we did done this one.
No, wasn't this the...
So the other one was absolute values. It's a similar approach, but now, in order to actually work it out, I have to draw this graph, or I have to show you that algebraic method that I'm about to show you. So this is my solution here, and I could draw it out on a number line as well, okay? Now, just as a note, what you'll find is the more of these questions you do, the answers will always be one of these two situations. The answers will always either be on these sides of the inequality, or they'll be within these intercepts, all right? And if you think about why, it's because you're either asking for when it's like above or when it's below the x-axis. And parabolas will always satisfy one of these situations. How do we feel about that? Not too bad?